Okay, guys, today we're going to learn about solving trig equations. So we've been simplifying and verifying with trig expressions and identities, and now we're going to solve equations using these functions. Okay, so some of this should feel familiar. We're going to use the formulas from that same formula chart and the unit circle. So keep those two things handy. You're going to need your unit circle and the formula chart. All right, so at the top of page 10, you can see the first problem says solve the equation for x, and we're just really trying to work our way back to that variable and figure out what number that is. So A says sine x equals 1/2. So that question basically is saying, hey, I know that the sine value is 1/2. Where is that happening? What angle is this, right? So I want that angle. And I can find this on the unit circle, right? Remember, sine is y on the unit circle. So where are we going to have a sine value that is equal to 1/2? So go ahead, take a second, look at your unit circle, find that 1/2 for me. And hopefully you came up with pi over 6 and 5 pi over 6. Now, those two solutions both have a sine of 1/2. And in this case, it is not restricted at all. I'm just saying, hey, aren't there some more solutions still? And you'd say, yeah, definitely there are more solutions. Remember, we could go around the circle more times. So let's think about how we could go around the circle more times. Well, to each of these, if I wrote plus the period times n. So remember, my period is 2 pi in this case, times n. 5 pi over 6 would give me 5 pi over 6 plus 2 pi n. All right. And so what am I saying by adding that 2 pi n to the end is that this pattern continues on indefinitely, either positive or negative, and I'm just going around the circle any number of times. All right. Remember, the 2 pi portion is the period of the sine function. Now, the first part of this might seem just like what we did previously. It's kind of like when we used sine inverse or arcsine to find values on the circle. You knew that, hey, I knew what the sine value was, and I was going to go find those two angles. The one extra thing that we've kind of added in there was this section about the period n, and the reason we add that is because we might have more than one rotation. So we always account for going around the circle more times. And in this case, we're just saying, yeah, absolutely. I could have pi over 6 and I could go around the circle any number of times, or 5 pi over 6 and go around the circle any number of times. Okay, let's take a look at problem B. So problem B is going to read tangent of x equals 3. Now, if we were to look at the unit circle and go calculate our tangent values out, we'd pretty quickly find out that, wait, I really don't have a tangent value that's equal to 3 on the unit circle. So how am I going to solve this? How can I figure this out? Well, sadly, we're stuck relying on a calculator for something like this when we don't have a real angle, or at least not one from the unit circle. We have no reference point, so we're just going to have to rely on a calculator. So to put this in a calculator, what we're going to do is we're actually going to solve it kind of like we did those right triangle problems. And we're going to go ahead and say that, wait, my x value is equal to tangent inverse of 3. And you should end up getting 1.249 radians. Okay, so I'm just going to note this is in radians. And we could have solved it in degrees. We can change it by multiplying by 180 over pi. But let's just leave it alone as radians. And let's take a look at kind of where this angle is. So the first thing is there is a tangent over here at this angle, 1.249 radians, that has a tangent of 3. Right? This is where tangent equals 3, and it is 1.249 radians. And that same angle is going to have a matching tangent on the other side, actually. Okay, and how would I find that one? How far apart are my blue and green angles? Take a second, let's think about that. I'm hoping that you came up with that they're 180 degrees apart, which is basically just going to be pi radians. So if we add pi, we'll get 4.391 also in radians. So we found two different solutions, and we're going to give them the same treatment that we had previously, right? Remember, I found two solutions on the first circle around, but what about the circle repeating itself as I keep making more and more revolutions? Okay, so same process, okay? We're going to just have our values, and we're going to go ahead and put that plus the period times n on there. So 1.249 plus, what's the period for tangent? Hopefully you remember that it is pi n, so plus pi times n here. And on this side, I'm going to have 4.391 plus pi n, okay? Remember, the formula for the tangent period is pi over b. And in this case, b was just 1, so we didn't have to mess around with that at all. Okay, if we just keep chugging along, let's take a look at C. So part C reads as 3 tangent squared of x equals 1. And there's just a lot going on here. I don't have the tangent by itself, so it's very difficult for me to just guess what that x value is going to be. No, I don't want to guess. So instead, let's work our way back and get tangent by itself. Okay, so what's going to be the first step? Let's start by dividing this 3 to the other side. And now I've got tangent squared of x equals 1/3. Now, I'm going to go ahead and break this tangent squared down as well. We'll take the square root of both sides. And tangent of x equals plus or minus square root 1 over square root 3. I just kind of split up those square roots. But notice, guys, I did make sure to put that plus or minus. When we take a square root, we have to be careful to make sure we do that. All right. We drew that square root, so we always add plus or minus. Now, this is going to be 1 over square root 3. And we're going to go ahead and rationalize that as well. And we're going to get root 3, root 3. And we should get square root 3 over 3. And it is plus or minus. Okay, so we're going to end up with some extra solutions here because of that plus or minus. So let's go to our circle and think, hey, where are we going to have plus or minus root 3 over 3 as our tangent values? So I'm hoping that you came up with pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, these are the 4 angles where tangent is going to equal positive or negative root 3 over 3. And let's go ahead and add that plus pi n to the end of these. So pi over 6 plus pi n, 5 pi over 6 plus pi n, 7 pi over 6 plus pi n, and 11 pi over 6 plus pi n. And basically what we're doing is the first set of answers that we had come up with, these blue ones, are solutions from one trip around the circle, which means just that first cycle of the unit circle, or however you want to look at it. Now, the solutions that are in yellow, on the other hand, represent when you haven't limited your distance and you are working on general solutions, meaning that you could go around the circle once, twice, you could go forward or backward as many times as you wanted. Okay? Okay, so let's take a look at problem 2 now. And you can see it says solve 2 cosine 3t minus 1 equal to 0 on the interval from 0 to 2 pi. And the best way to think about that is I only care about answers that are specifically in between 0 and 2 pi. So basically, we get to skip that last step that we were having, that part where we were saying plus 2 pi n or plus pi n based on the period. So we're going to go ahead and start this problem off the same way we did that last problem with the tangent squared. We're going to go ahead and get cosine by itself. So we'll start by adding 1 to each side. And we've got 2 cosine 3t is equal to 1. And we'll divide by 2. And I've got cosine 3t equals 1/2. And you'll notice I haven't even brought up the fact that this said 3t. Instead of just being a single variable, it's got that 3 there. Now, this is where it's going to kick in. So first, we're going to go ahead and figure out this problem the same way that we have been doing. Okay, we've been saying, like, I'm going to go to the unit circle and find the solutions based on that. So where is cosine 1/2 on the unit circle? Take a second and look at your unit circle. So if you paused the video and looked at your unit circle, you should have come up with pi over 3 and 5 pi over 3. So now let's take this 3t into account. Okay, so how do we handle this 3t on the interval? Well, that 3t means we're actually going to not just go around the circle one time, but we'll end up going around the circle 3 times. So how am I going to get my solutions? Well, my first revolution had 2 solutions, okay? So my second revolution is going to have another 2 solutions. And how am I going to find those? Well, we're just going to go around the circle and we're going to go ahead and add 2 pi to this, okay? And if I add 2 pi to each of these, pi over 3 plus 2 pi, I'm going to get 7 pi over 3. And I'm going to get 11 pi over 3. So that's one more circle around. Let's go ahead and do it again. Add 2 pi again. And we're going to get 13 pi over 3 and 17 pi over 3. Okay, so, and now you can tell that in red, I've got the first circle. Then I have 2 more circles. So this is the second revolution, and this is the third revolution. Okay, and these values are all equal to 3t. Okay, and so finally, to actually get my normal value, my t value, I'm going to divide by 3 for all of these. Okay, and you should just note 3 times around the circle means 3 times the solutions. So normally on the circle, you can have 2 solutions in that first rotation, but since this was 3t, I have 2 times 3, 6 total solutions. And to get those final solutions, we're going to just divide this by 3, because again, this was 3t. Our final answer is going to be divided by 3. So let's take all of these numbers we've got, and we're going to divide them by 3. And you'll see there's a pretty easy pattern once we start doing this. The first answer I get from pi over 3 is going to become pi over 9. 5 pi over 3 is going to be 5 pi over 9. 7 pi over 9. 11 pi over 9. You're already starting to discover something here. 13 pi over 9. and 17 pi over 9. And these guys are my final solutions for this. Okay? So once again, we're saying, hey, for this 3t, I'm going 3 times around the circle, which is going to give me 6 solutions. For each revolution, I'm going to go ahead and add 2 pi. So I have my first 2 solutions that I got from the unit circle in red, and then I add 2 pi to them twice to find 2 new sets of solutions, giving me a total of 6 solutions. All right? Generically, you'll have 2. That 3 triples my number of solutions and gives me 6. Now, don't forget at the end, you have to divide by 3 because this was solving for 3t. And so after that, we'll have 6 different solutions for t, and those are going to be my values. Now, here's kind of an interesting thought. What if we were solving this and we didn't have an interval? Okay, so just an interesting thought point. Let's see what would be like if we didn't have an interval. All right, so same kind of thought process. We were at the point where we solved this 2 cosine 3t minus 1 equals 0. And when we solved this, we got cosine 3t equals 1/2. And the first 2 solutions that I knew were pi over 3 and 5 pi over 3. Now, the nice thing about this is if we were solving this without an interval, we can very simply get all the solutions in one go. So I'm going to go ahead and say, hey, look, here's pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. We just have to remember that we solved for 3t here. So to finish this problem off, all I'm going to do is I'm going to take these two answers and I'm going to divide them by 3. And I'm going to end up dividing this whole statement by 3 and this whole statement by 3. Now you could go piece by piece. Pi over 3 divided by 3 gives you pi over 9 plus 2 pi n over 3. Okay, you can also write it as 2 pi over 3 times n. And we've also got 5 pi over 9 plus 2 pi n over 3. So this example, guys, I just went on a little bit of a tangent talking about without an interval solutions for something that has multiple answers like we did previously. Okay, so in this case, each of these is a set of solutions, and you can see it's based off of that first solution plus the period, but we have to make sure to divide both of them by that 3. Okay, now let's look at problem 4. It says cotangent x times cosine squared x equals 2 cotangent x. And they've given us an interval as well. Okay, this little piece at the end is the interval. So I want solutions from 0 to 2 pi. Again, that's my first revolution. Okay, so all solutions are only between 0 and 2 pi. Okay, and this is kind of an interesting problem. We've got nothing that really matches up, nothing to combine, and I have 2 different types of trig functions. So one suggestion, why don't we go ahead and get everything onto one side? So the easiest thing that comes to me is let's go ahead and just subtract this 2 cotangent x from each side. And we can't really combine anything, so I've got cotangent x cosine squared x minus 2 cotangent x equals 0. Well, at least I've got everything equal to 0 now, and I can work on everything on the left side. Now, I notice each of my terms has this cotangent x. So I'm going to just take a second and try to pull that out. We're going to do that by factoring out. So if you can, go ahead and factor out that cotangent x and see what you get. Cotangent x, and I've got cosine squared x left over there, and minus 2 inside, and that is going to be equal to 0. Okay. Now, individually, each of these factors can be equal to 0 and give us its own solutions. So for example, this first part, cotangent x, can be set equal to 0, and the second part, cosine squared of x minus 2, can be set equal to 0 as well. And we can work our way down through each of these pieces to get our solutions. So let's start with that first one, that cotangent x equals 0. So we can just go to the unit circle and we could hunt down some areas where cotangent x equals 0. If you're not sure, remember, this is the same place as where tangent is undefined. So this is going to be at pi over 2 and 3 pi over 2. Okay, now let's take a look at cosine. Cosine squared x minus 2. Let's go ahead and simplify this down further. Let's move this 2 to the other side. Cosine squared of x equals 2. And now what am I going to do? Let's take the square root. So if I square root each side, let's not forget about our plus and minus. And now we're thinking, hey, wait a minute. Is my cosine x going to be equal to plus or minus 2? Is that possible? No, that one actually doesn't give me any solutions. This number is too big, and it's not in the range for cosine because it is not between -1 and 1. So this is not going to be giving me any solutions from here. This side gave me two different solutions, pi over 2 and 3 pi over 2, and they are on my interval, so these are going to be my answers. Okay, so these are in the interval 0 to 2 pi. Okay, remember, in the interval means we don't add that plus pi or that plus 2 pi in notation.